Hello, hi. So today I have picked one interesting problem, which is consistent hashing algorithm. So I will discuss what is the consistent hashing algorithm and how is different from the normal hashing and what is the different use case of this algorithm and what are the practical application and what are the places it is used. In the last, I will also talk about the its implementation in Java. So okay, so let's let first understand the uh, where it is used, where it fit, right? So first, let's think about the distributed system. While we need to scale up or scale down the server, right? So server can be any type of server, like application server or database server or some DB server, cache server, right? So it can be any type of server. So when we need to scale up or scale down, we just need to add another server or remove existing from server pool. Where this is where the this come into picture, right? So problem with the normal hashing, when we go with the normal hashing, so there is a problem I will discuss. Let me discuss the first problem. What is the problem if we go with the normal hashing? Okay, so let me just explain this one. Okay, so let's suppose we have initially we have four servers, A, B, C and D, which I have mapped to index 0, 1, 2, 3. Okay, and these server are caching server which cache the data of the users. Okay, so whenever we like we have sorted the cache uh, of the user database, cache the data of the users into different servers. Initially we have sorted into four servers. Okay, let's think of initially four servers. So some of part of the users, let's suppose we have millions of users, and some part of the data persist in server A, some part of the data persist in server B, similarly in server C and D. Okay, so initially we have four servers, and we get the request, and we take a hash, we apply the hash of this cache key, and we get the hash value and take a modulo, and we get the server which have the uh, that user data. Okay, so if you see that in on a screen, I have written some of them how it will goes. So initially we have four servers. Once we get the hash value, we divide by 4, we get the some value, like let's suppose we get the server first server A which at 0 index. So it we will get the data. Okay, so case one, when server never change, we have fixed set of server. Okay, never change, neither be added, not be removed from what we have initially. Okay, so in this case, when the server never change and we have fixed set of server, in this case just simple hash function will work. We get the key and has cache key, means user ID. Let's suppose the user ID is the cache key, and we get the hash value and we take a modulo of by the hash value. So which is initially 4, we get the number which server will have this user data. Okay, so till now this is working fine. Okay, so suppose we get the traffic at any certain point, suddenly we get the traffic double, you add another server to existing. Now we have a total number of 5 servers. With applying the same formula, if we applying the same formula, then maybe some of the hash key hash value will get the another server which don't have the don't have that user data. Then we get the cache mismatch, miss, right? So we get the miss cache miss. Okay, and it hit the database. And this can be this may be most of the server will get the cache miss and hit the database, and database get hammered. Okay, and a lot of the request goes to the database and database may goes to down. Okay, so in this case, one solution is we need to move. One solution is either when we add a new server, we need to recalculate all the uh, all the cache key and move to the respective server where we get the calculated value. Okay, so that is expensive operation. Suppose we have initially, suppose I have taken the 2000 keys, right? So suppose we have total 2000 keys uh, uh, in a in our cache cluster. Means each server have some of the cache user cache data, and we all these we need to remap, recalculate, and we need to remove into uh, different server with the adding with the new one server, right? So this is the problem. So this problem uh, solved by the consistent hashing. Consistent hashing, this instead of inst inst using consistent hashing, instead of we need to put all the keys to recalculate. All the keys get affected in normal hashing. In consistent hashing, in a few using consistent consistent hashing, only few keys will get affected. Affected means need to move out, need to move. Okay, let's understand how it. Okay, so let's assume instead of thinking server on the list where we have we get the key cache key, we calculate the hash value, and we take a modulo by n. Instead of thinking of in terms of list, let's think, imagine all the server a point on a circle. Okay, so let me just remove it. Let's think all servers are a point on a circle. Okay, so now we will uh, calculate as of server. Let's name it node. Okay, node. It will be like server ID or node ID. Server ID or node ID, and we will calculate the hash, and this hash value will place into a ring. And let me just put it here to get more clear. Okay, so let's suppose I have taken server A, server B, server C, and some random value, which is hash value of server A is 100, and hash value of server B I assume 300, which is this one, and random hash value of server C is 600. Okay, I have taken some random value to explain this issue, explain the algorithm. Okay, not issue. So I have put all the server in the ring, on a ring. So for any key, we get a we get a request to get the user data, and we calculate the hash value on the user ID uh, to get the we get the hash value. And now for this hash value, and we will move to in clockwise direction. Okay, so think of this is a ring has point of point any number between 0 to uh, till maximum integer like to the power 21, 22 minus 1. Okay, maybe think, let me just wait. uh, ring has a points between 0 to the power 32 minus 1. Okay, this is the value which we need. Now we are hashing both uh, user id means and server id both, and for any given user id we calculate the hash value. Okay, for that hash value we will go to the clockwise direction. Okay, we will go to the clockwise direction until we get a server, and once we get a server, that server will have that key data. Okay, so let me just, here are some messy things, let me just put it here. Okay, okay, now suppose user id 1 hash value is 200, and 200 lie between the server a value and server b, and b go to the right clockwise direction, we get the server b. Now server b will have the uh, user 1 data, cache data. Okay, it will get server from server b. This is the concept of the consistent hashing. Suppose somehow server b goes down. Okay, if server b goes down, all the keys between server a and server b which is present on server b will be moved to server c. So now instead of affecting all the keys present in the ring on a cluster, we only need to move fraction of that keys uh, to the server C. Okay, so now after moving all the request, all the hash value of the user IDs between the server A and server C will be served by the server C. Means uh, now server C have all the data. Okay, between these range. So this is the this is how consistent hashing solve the normal hashing problem. Instead of remapping or moving all the keys, we only need fraction of keys need to move to the uh, next server who serve that request. Okay, but there is a problem also, right? This server, all these server, we calculate hash, and this hash value put on the ring, and this is randomly distributed over the ring. Okay, this is randomly distributed over the ring. Suppose server a have a larger arc, means server value of server a and b is too closer, and most of the request will serve by the server a, and server a may be overloaded, and server B and server B may be under load with the same configuration of the server. Means suppose server A and server B, server C both have same CPU, same RAM, and one of them is serving more request and other are in under the role. Okay, so that's another problem we have introduced. So this problem is solved by introducing the virtual nodes of the each server. So I think you get the problem. Suppose as here in this problem, uh, I have explained here somehow. Let me just go to the suppose server A has value 100 and server B has value is 150 and server C has value is 200. These are too closer, right? Each other too close, and only few request, only few hash key which lie between the server A and server B, means 100 and 150, that will be served by the server B. Okay, means that only have data on a server B. Similarly, between 150 to 200, whatever the cache data will be there only in server C, that will be the major portion of the this range will have a on server A, means it is not evenly distributed, right? So this is another problem. So this problem is uh, solved by the, if we we introduce the uh, virtual nodes. So virtual nodes concept is like, uh, if we, instead of putting only one, thinking of only one instance of server on ring, so instead, it's virtual, not real. Instead of thinking uh, only one server, only one instance of server on a ring, let's let's put 200 replica of same server on a ring. Okay, so this this way we can evenly, more evenly distribute the data among across the set of servers. Okay, so suppose we have replication factor 3, then we can replicate like, server has 1, server has 2, server has 3, similarly for server B, similarly for server C. Okay, this is virtual ring. So now instead of putting only one instance, we are putting uh, more than one, means 100 times or 200 times of same server on a virtual ring. So by, for each server ID we put the hash, and with the index 123 we get the different hash value, and so this is how we can evenly, more evenly distribute the data across the server. Okay, instead of putting into a button on single server. So this is the all about the consistent hashing, and there is a trades of, I will also I need to also discuss. Let me just some trades of which is this have for introducing virtual node. If we introducing more virtual nodes, means more replication, uh, replica of same of any server, we introducing like memory overhead, like we can't like replicate thousands of replication. We get, if we get thousands of replication, we get evenly more distribute request and database, whatever the data across the server. But we also introduce the memory overhead, like also we introduce the memory overhead and time complexity when we going to search that node for a given key, that also introduce the time complexity. uh, Even we have introduced the virtual node, but it is possible evenly, uneven distribution is still possible. Okay, so it not 100% uh, evenly distributed in all scenario. Okay, but it is acceptable. Okay, and third point is like hash collision on the ring. Suppose two different virtual node landing on the same position. So this is the trades off, but this trades off we can avoid by some mechanism. One is like hash collision. We can use like different better hashing algorithm which give the better distribution across the bit, like murmur hash function we can use, which give the 64-bit space, and very few negligible uh, and it will produce very few negligible collisions. Okay, so but in production system we need to handle it. Okay, so I think I have covered all of the point related the consistent hashing. So this is practical application of this algorithm is used in like distributed cache and Cassandra. If you ever use the Cassandra database, so where the replication factor, where we replicate the data across the multiple nodes. So we use we have also we this algorithm also used in Cassandra, and in somewhere is also in DynamoDB, and there are multiple use case in internally in different kind of uh, database and cache cluster. Okay, so let's move the implementation part of this algorithm. So I will walk you through the implementation code in Java. So let me move to that part. Okay, so I have uh, defined a class which is consistent hashing, and I have taken the default replica count 150. I have taken a tree map which key have a hash value as I have discussed, and value as a server ID or node ID, and second is node with the replica count. Means one things I want to let you know, like uh, suppose we have a different kind of server, like different capacity of servers. Okay, means where we introduce weighted server. Some server have more weight, some server have less weight, like more power, and some server less power. So according to the power, we can define the replica. We can define the virtual node. Like suppose uh, server A have a 64 GB RAM. Okay, RAM and server. Then this can have more replication, so that replica count. So that replica count means actually it's a virtual node. It defines the virtual node. So so that request get evenly distributed over the across the server according to the their weighted. Okay, so I have defined the three constructor. One is private. Making private default constructor is reason behind it, uh, so that user won't able to call without passing initial nodes. Second one is the taking the list of nodes ID, and third one is the node with the replica count, which is for all the nodes. Uh, for all the nodes, we have same count of virtual nodes. Okay, because this is same for all. If we have weighted server, where for each node we have different replica count, then we can map to that those also. And for tree map, this is what I have taken, because I need for every key I need mm, for every cache key I get calculate the hash value of that cache key. Okay, and that hash value I need the next greater element for that element. Means we need to find out upper bound of that element that has value, upper bound of that has value. So we need sorted order, we need in sorted order. So tree map that is handled in good complexity, time complexity, which is logarithmic log of n number of the server. So this is why I have taken tree map, which for insertion, for adding a server, for removing a server, this maintain the sorted map. Okay, and this is has I have utilized the internal inbuilt Java hash code for uh, for this implementation. But in production, we will prefer the Murmur hash code, which will get the better distribution over the 64-bit integer. Okay, but it give the 34-bit integer. Okay, it give the 32, not 34, 32-bit integer. And this is similar what I have discussed in my earlier video, where I have designed the custom hash map. This is similar concept. This is for the avoid the collision, provide the better distribution of the bits. Means upper 16-bit get mixed with the lower 16-bit, so that it will get better distributed across the 32 bits. Okay, so this is how. And third point is like, once we get the hash, and this can be a like unsigned bit, right? Can be negative value also. That's why I have taken long value integer. So for long value, I making it make I applying a bit masking of 64-bit. So this is bit masking of 64-bit, where each f is like, you know, that 4 bit each hexadecimal format. And if you calculate this, this is the largest maximum uh, largest integer in which is signed one, right? Largest positive integer. Okay, so, so this 7 is represent the, what is it represent, 1 1 0 1. If you take it 4 bit, then it will be 0 1 1, which is 7. Then if we bit masking, if we get any negative integer, then first bit is signed bit, right? Then if we take AND operator, then it will force to the positive numbers, right? It will force to the positive numbers. So that why I have apply the bit masking here. Okay, so there are main function, main method. I will let me show this one. Add a node. So I have defined a overloaded add node method, where one in first one we can pass the replica count. In second one, if we not pass the replica count, it will take the default replica count. Then it will add. So first it will check whether it already added. If not added, it just put the replica count with the node and its replica count, and it's add the virtual nodes on the ring. So virtual nodes is concept is so simple. We just iterate the all the count, and we just calculate the hash value for node, and appending the hash and the index, we get the hash value, and just put the hash value and with the node value, server id, means hash value with the server id. So this is how we are putting the virtual node on the ring, and in last we put map the actual node value with the replica count. Similarly, for removing the server, first we will check whether it contain. If contain, we just get the replica count. We for replica count, we just remove from first we remove from all the virtual node from the ring from here, then we will remove from the main mapping. Okay, here is the main things like where we need to get a node for a given key. We get the key and we calculate the hash value, then we get the ceiling entry with the upper bound of that hash value. We get that entry. If entry is null, means none of the value is greater than the current value, then we will just map to the first value, and we just return the node value of that key which will have that data. Okay, second things I will mention here, like how you will add handle, either you handle the collisions, either you will add a better hash function like murmur hash 3 to get the better collision handling. Either you can attempt here like uh, I will, while adding there, before adding here, we can just check whether it has it already exist. If already exists, we can attempt, we can add another key, append another like attempt id to get the another different hash function, different hash value. Okay, for that new key, but it will add a more complexity. For simplicity I have just not going into that. So this is all about the implementation. I will put this implementation video description. You can check out from there, and for any query and question you can comment in the comment box. Okay, thank you.